Doing well. So this we have completed with the orientation session. So now the technical session will start. So I welcome everyone to the Statistics and Exploratory Data Analyst Week 1 live session. And today we have instructor Dr. Sandeep Kumar here. So before starting the session, I request everyone to please stay on mute until and unless that you have a doubt. And also use the chat only for the subject related queries. And if the instructor is asking any question or anything, try to respond over the chat box because too many students are unmuting because the session may cause disturb, and also the instructor cannot understand what you are exactly trying to convey. So I hope everyone have got this. Can I get some response in the chat box? Yes, thank you guys. Thank you for acknowledging. And let's begin our session. Let's welcome our instructor, Dr. Sandeep. Hi, Sandeep. Good morning.
Good morning, Ravi. Good morning, everyone.
Yeah, just a minute, Sandeep. Also, guys, I request everyone to please set your chat setting default to meeting group chat so that whatever your message you are posting in the chat box, it will be visible to instructor and other students as well in the chat. Okay. So try to set the chart setting to meeting group chat. All right, let's begin our session. So Sandeep, how are you?
Sure, Ravi. So, guys, as you know that we are going to start from statistics and EDA, but before I will introduce myself. So, Ravi has already mentioned my name is Sandeep Kumar Singh. I have done my states. I have also worked there. I have also worked in Denmark, and right now I'm just going to work with you on statistics and EDA. So, can you tell me what is stats? If again, I'm not expecting that you know, but I just want to know what does statistics means to you?
Statistics mean collecting sample and
Yes,
give result as average or median sum.
sure. So statistics is basically it's samples and try to get some information based on that. Okay, we are trying to get some information based on that about our data. Okay, so this is what statistics mean. Okay, so again is like why is it important? My second question is you can write in chat also, but
Hello,
can you
sir.
tell me why is it important?
Sir, you are not visible, sir.
No, I have opened my webcam, so it is taking some time for some reason. So as soon as it comes out, I will be visible. Okay.
For analyzing data.
Okay, for analyzing data.
So we can say, sir, it simplifies complex information.
Yes.
It can
Statistics,
make decisions.
statistics actually helps us to simplify complex information. Okay. This is the main purpose of statistics. Okay. So again, when we are in the field of data science, so the what is the main word we are hearing? When we talk about the data science, what is the
Data.
main word?
Sir, it's data.
It is data. So that is the most important thing in the field of statistics or data science or in any other field. If you go to any other field, we have to, we have to go and utilize data. So we will start from data. What is data and how are we going to use it?
Data is collection of information.
Okay, perfect.
collection of raw information which have to be further processed.
Okay, sure.
Data is collection of something, text or image, video, anything.
Perfect. So data is actually whatever the information we are putting into our system, like when you have a Facebook account, social media account. Okay, so what happens is whatever we are putting there, it may be a number, it may be a text, it may be a video, it may be an audio, all of these we considered as data. Okay. So guys, just give me 2 minutes because of webcam. I am not able to share my screen. I will be back in 2 minutes. Okay. I'm back. So I have not shared my screen. So please let me know if you guys are able to hear me.
Yes, you are audible.
Okay, perfect. So I will share my screen and I will go ahead with everything. And but beforehand, when we when we talk about data, so whatever that, remember one thing, that there is a concept called garbage in, garbage out. So what does it mean is if your data is good, okay, if your data is good, are we good to go or no?
It's still loading.
What is still loading?
Your screen, it's not yet visible.
Yeah. So that's I'm trying, but I may have to because the webcam has hanging for yeah. So it should come now. So, so my question was, if I say when we are dealing with the data, so if we collect data properly, is it good or not?
I mean, after we collect data, we are supposed to clean our data based on our problem solution or whatever.
That is true, but even for that, data collection is very, very important. Cleaning in everything is done later on, but the first thing is data collection. The first and foremost thing is data collection. Okay, we have to collect our data properly before moving to anything else. Why? Just for example, Hyderabad population. Okay, and rather than
I don't know if it's for me, but Sandeep sir, you are not audible. Your voice is breaking in between.
Sir, can you teach us with the help of marker and whiteboard, with the help of chart, as we can understand much better than this?
Students, as we informed earlier, please utilize the chat box because too many students are unmuting at the same time, so we can't able to understand. So drop a message in the chat box so that the instructor will be see that. Okay. And the instructor is rejoining in a minute. I request all of your cooperation and support.
So guys, let me know if you are able to hear me now. Okay, perfect. So it is due to, I think, webcam. So I will fix my webcam during the break now. Okay. So let's go ahead with the set point. So let me open the Microsoft Word and share my screen. So please let me know if you guys are able to see my screen.
Yes, Sandeep, it's visible.
Perfect. So as I mentioned about the data, so the first thing is data. The most important thing of any study. If data is collected wrong, then everything is wrong. Are you getting this point? So again, guys, I have a habit to ask questions, but I'm not expecting that you know everything. Okay. So it is just to make session more interactive. That is why I am asking. So my first question is, so how can a data affect your result? This is my first question. So guys, please don't do that because it is only affect the session and the flow of the session. How can data actually affect everything? If my data is not collected well, so what will happen? What will be the end result?
I mean, we end up, analyzing.
Yes, that is very, very important.
Yeah,
So
we
what if, because that is what we say, garbage in, garbage out. So the example I was giving to you guys was, if okay, yes, someone was saying something. Okay, so what happens is, just for example, like if I say one thing, we are collecting data. The example I was giving earlier, you want to do a study on socio-economic status. Okay, and you are collecting data from the whole Hyderabad. Okay, so we have the Hyderabad population. So for example, say if I say this is Hyderabad population. Okay, what you did, I selected two students from this class. For example, if I say Ajay and if I say Shiva, I asked them to, you have to collect data for me. So what Ajay did, Ajay just went to high-tech city and collected the data. And Shiva went to everyone in the population. Basically, he tries to go to everyone and collected the data. So whose data is collected better? Is it Ajay or is it Shiva? It is Shiva. Okay. But in real life, is it possible for us to go to everyone and collect our data? It is also not possible. So what happens is when we are doing data collections, when we are going for data collection, so what we select is we don't go for the everyone in the population. We try to get
Sample.
sample data. So there are two very important terms in statistics which we all have to remember is called population and sample. Okay, and I will share this sheet with you at the end of the session also. So if you want, you can also make your notes, or I'm also going to share this with you. So sample and population are two very important terms used in statistics. Okay, so why? In real life, we will never, technically, we are never going to, get information from everyone. So when we say population, so population is nothing, the entire group of individual. Okay, basically means the entire group of individuals. Okay, when we say sample, sample is subset of population. Okay, subset of population, but representing population. Okay, if the sample is not representing population, your study will go wrong. So these are two very important terms we have to remember. And remember another very important thing about population and sample is when we talk about population or sample, it doesn't mean I am just talking about human being. Okay, so don't take it as like we are talking about human being. For example, if you have to do a study on cell phone, then your population is, if you are doing a study on cell phone, then what is your population?
All the cell phone brands and cell phone
Yes,
brands.
the population is all of those cell phones. But what will you do? You will just select a subset of those cell phone and then do the study. If I say you are doing a study on, just for example, some animals, then your population is that specific animal. So this is very important. If I say you are doing a study on elderly population in India, so then what is your population?
All the elderly people groups.
Yes, all the elderly people group. So these are the very important terms. And when we are selecting the sample, so those samples should also be the elderly people only. They cannot be anyone. Okay. Okay. Now come to another very important point, another important term. Okay. So this is called parameter. Parameter is, it is basically the way to describe a characteristic of population. Okay, parameter is nothing, it is describing characteristics of a population. And now the most important term is statistics. This is what we are going to learn. This is what we are going to learn. So what is statistics? Parameter is describing characteristics of a population. So what is statistics then? So it is nothing, it is describing the characteristic of sample. So that is why we call it statistics. Okay, so this is the basic difference between parameter and statistics. Why I'm telling you is when you read papers, just for example, when you go and start reading more papers, articles related to data science, so you are going to see these terms. Okay, so whenever people will explaining population, they will use parameter. Whenever people are talking about sample, they will use the term called statistics. Okay, so is it clear what is the basic difference between parameter and statistics?
Sir, what does the characteristics exactly mean? I'm not able to get this.
We will discuss. So
Mhm.
characteristics is basically your descriptive statistics, which we will discuss today. Like what is the average of the population? What is the most frequency of the population? What is the distribution in your population? So these are the characteristics. Okay. For example, if I say the total students in the Odin school, so that is my population. Okay.
Mhm.
So if I say Odin school is my population, all students who are studying in Odin school is my population. But if I have to check how good are they in statistics, I will technically it's not practically impossible that I cannot go for. I will select samples from this. Is my voice breaking?
Yes, yes, sir. Your voice is breaking.
Yes, yes.
Yes, yes, sir,
Okay.
your voice is breaking.
So let me check. So is it better anyway or still breaking?
Now it's better.
Hmm?
It's better now.
Okay.
Now it's okay.
Okay. So when I say population, just for example, Odin school, students at Odin school. All students at Odin school is my population. Okay. But if I have to check how good are you in statistics, what I am going to do is I am just selecting subset of students who have taken statistics. Okay. Basically, all students at Odin school who has taken statistics. Similarly, subset of students who have taken statistics. Now, if I say let's calculate the average value. Okay, let's say calculate the average value. So what I'm going to do is uh, simple is if I say average okay, so if I say average of
It's again your voice is
whole Odin school, okay, students. So this is my parameter. If I take the average of all students at Odin school, this is my parameter. But if I say I am just taking the average, I'm just taking the average of sample selected, then this is called statistics. Is it clear now? What is the basic difference?
Uh, so basically, statistic is taking the average of the relevant selected data, right? The sample.
No, I am just giving you one example of statistics that is average. There are many things in statistics like average, median, mode, standard deviation, variance, IQR. So we collect Excel, we do all of those. So these terms may be,
Yeah.
yeah. So when we do it for sample, then it is called statistics. And when we do it for population, then it is called parameter.
Yeah, right, correct. So, yeah, that is very correct that we are having average and mean median mode, but it's on the relevant sample data, right?
Yes, it should be, sample should always be relevant. Sample should always be relevant.
Okay.
Okay, if it is not relevant, we will get biased result. So parameter is calculating average on all students at Odin school. Okay, if I say I have 500 students here, okay, 500 students in the, just for example, at Odin school. Okay, this is the number of students at Odin school. And I have selected 100 people sample from here. Okay, 100 samples only. Now, if I go and calculate average for all of these 500, it will be called parameter. And if I do the same thing for 100 samples, this will be called statistics. Is it clear now?
Sir, but one small question. The population. So this population is also done on the relevant, right? The all the students at Odin School who take statistics, right?
Yes,
Or
all students at Goodin school who takes statistics, who took statistics. Okay, all students at Goodin school who has taken statistics. Okay, so this is my population. So just for example, I have 500 students who has taken statistics at Odin school. Now what I did, rather than going for all 500, I randomly selected 100 samples. Okay, 100 samples from this. Now if I go and calculate average of these 500, this will be called parameter. If I calculate the average of these 100 samples, this will be called statistics. So is it clear? Everyone. So please write in chat also, like if it is clear. If any doubt, please let me know. So we will go accordingly.
Hi, Sandeep.
Yes,
I got the point what you are explaining, but thing is, I have a question. Like,
yes,
see, on the entire population and the sample population. So
yes.
we are,
So remember, when you say sample, they never use the term called population.
sorry, yeah, entire population and the sample. Sorry.
Yes,
So while I am drawing my assumption and all, I will be doing it on the sample, right? So
yes,
when I look at the population, it is like the larger data set. So why do we draw our assumption or analysis on sample rather than doing on a larger data set where we can have more scenarios and all, right?
yeah. That is perfect question. So the question is, why are we doing it on sample, not on population? There are many things. Okay, so there are many issues when we go for the population. Number one, population may be moving. Is it or not?
Yes, true.
So someone who is in Hyderabad may be in New Delhi. Another thing is, just to imagine, if you have to do a study which is costing you 50 lakh rupees for 10,000 samples. So now tell me how much will it cost if you have to do the same study if you are going for 5 crore, from 10,000 people to 5 crore people. So is it not going to cost a lot of money?
Yes.
Number one. Number two is, reaching 10,000 people may take you 2 to 3 years. When we do the sample selection, it takes time. Okay, it takes a lot of time. Now tell me how much time is it going to take to reach 5 crore people? So all of these we have to take in consideration when we are doing it. Most of the things, what happens is, if you just look at European data, because I was in Denmark for like 1 year. So when a kid is born, so from that time they have started collecting the data. So they have all information about their population. They have all information whoever is coming to their country. But in a country like India, when we have 140 crore people, it is tough. Okay, government actually wants to create something like this, but it is going to be tough. We still don't have. So if we have to do any study, we have to get assumptions from our sample. So whatever when we do, we try to get assumption. Like whatever we see in our sample, we try to assume about population using that sample. Is this point clear? So here is a good image I created earlier. So if I show you this, if you see this image, so this is what actually happens in our life when we do the study. Okay, so now we are in the era of big data. So mostly what you are going to see is, we are going to have these samples. We are going to have complete population. Maybe in future we will get it, but right now it is difficult. So what happens is, we are doing a study on a population because it is not practically possible. What we do, we collect sample. We collect sample from this population using some sampling techniques, just like random sample. Random sample is like, if I say I have 5 crore people in Hyderabad, what I did, I put everyone's name in a box, then mixed the box very well, and then just selected 10,000 people from that. So that is what randomness basically means. From everyone, I am giving chance to like everyone in the Hyderabad, I'm giving chance everyone to be part of my study. So that is very important. So your sample should always represent your population. Okay, our sample should always represent our population, and then whatever the result we get, we try to get the inference about our population. For example, if my mean came, for example, I want to see what is the average age of Hyderabad, and my mean came just for example 35. So this is what I am going to assume. From this sample, I am going to assume the average population, average age of Hyderabad population is 35. Is this point clear now?
Yes, yes, Sandeep.
Everyone? So this is the way, this is the basic fundamental behind statistics. Okay, this is the basic fundamental behind statistics. Okay, so let's go and do a simple data collection with you guys.
So,
So
Sandeep,
let's,
I have a follow-up question, Sandeep.
yes,
So, while collecting the sample, so how do we ensure that all the, scenarios are what are all the different, say, let's say, population is very huge, right? So
yes,
there are like it will be of a mixture or multiple scenarios. So how do we ensure while collecting our sample, so we don't miss out any of the such conditions? I mean, such scenarios.
perfect. So that is the perfect question, because this is very important, because if we miss, our results are wrong. So for example, if I am doing a study where males and females are important, okay, they are very important. So what I will do, I will have one sample of males and another with females, and then I will do the collection. Okay, is it or not? If I say socioeconomic status is very important, then what I will do, I will create a strata of socioeconomic status. Okay, so strata of socioeconomic status. Okay, and then just for example, if I say what is my strata, very poor. Basically, we have to define what does very poor means. Poor, lower middle class, middle class, upper middle class. So this is the way we can define. We have to define very well what does my population means, and then we have to do the correction. Okay. So whatever the variable we are going to select, because when we are collecting our sample, we have to define our all variables. Okay, and we will discuss in a minute what does variable means. Variable basically means whatever the columns we are going to select in our data set. Okay, so just for example, let me go ahead and, so are you able to see this spreadsheet?
Yes, sir.
Okay, so just for example, if I say I am collecting our data in this class only, so all of you must be having an ID. Is it or not? Student ID. Then you are having name. Then I have your gender information. Okay, I have your occupation information. I have your education information. Okay, and then just for example, I have your stats information, stats score information. Okay, I have your Python score information. Okay, are you working or not? Okay, I have all of your those info. These are your variable. These are your variable. So we have to define all of these first. Okay, so whenever we do, this is called study design. So we have to design our study well, and then based on these, we have to go and collect all of these information. Okay, if there is gender is important, so we have to be sure that I shouldn't be having a sample like this. Okay, gender is important, but males are 90% and females are 10%. So this is not good. Is this good? Gender is very important, but we are seeing something like this. It can be 60-40. It can be 65-35, but it cannot be like this. So these things we have to take care in advance before going for sample selection. Is this point clear?
Yes, sir.
Is there any technique for collecting the sample or
The
choosing the
best way
sample?
is random sampling. Okay, there are many approaches, but the most commonly used approach is called random sampling. Basically means if I say I have 500 students in this class, okay, socio-economic status. SES basically means socio-economic status. Basically means if a person is poor, if the person is middle class, if the person is coming from rich family, what does it? This is what it means. Is it clear now? Okay, perfect. So
Sir, when we are hello,
yes.
sir, when we are sampling the data, how we will ensure that it's exactly reflecting the population?
So that is what there are multiple methods. One of the most commonly method is called random sampling. What does it mean is if I say I have 500 students in this class, okay, I have information about all of you guys. Okay. So what I am going to do is I am going to put all of these names into my system. Then I will just call a Python code, R code, or Excel to do a random selection of 100 students. So is it not I am giving all 500 students to be the part of my study and just randomly selecting 100 samples. So there is like 99.99% chance that these 100 samples will definitely represent these good people. Definitely represent these. So this is what we do. For example, like now we all have cell phones, is it or not? Most of the people who are 13, 14 years or above, all of we have cell phones. So simply using cell phone numbers, we can do the sample selection. We can just go collect from all phone numbers from the cell companies and do the random selection. Government is actually having all of technically having all of those data. Those are who are living legally in India. All of our information government has just in the form of Aadhaar card. Is it or not? Like PAN card, those who are paying taxes, they have PAN card information. So Aadhaar card, whoever is like Indian citizen, now they have also Aadhaar card is for foreign citizens too, but Aadhaar card is applicable for Indian citizens. So we have all of those information. The government is having all of those information. So if you go to a bank is having all of your information. For example, I want to do a study in a specific bank. So can I not get all information about everyone? For example, just for example, State Bank of India wants to do a study who will take credit card and who will not take credit card. So do they have all information or not? Whoever is registered in their bank, they have all information about everyone. Is it or not? Whoever is registered. So what they can do, they can use all of those name into the system and then just randomly select 10,000 people and do the study. So when we do the random selection, there is a 99.99% chance your sample will represent your population. Okay, 99.99%. I will never say like 100% accurate, but yes, 99.99 is a very, very good number. Is it clear now? And this is called stratified sampling. For example, when you are saying uh, you want to be very sure that male and female should be having equal, you can simply use a stratified sampling. This is called stratified sampling. So this way you are very sure that all people from male and males and females are having equal number in our study. Similarly, this is also an example of stratified sampling. So you just want to be very sure about socioeconomic status. So you divided everything into strata and then selected the sample. So this way you are going to have people from each and every strata. So these are the methods. Is it clear now? These are the methods to be very, very sure that you are selecting, going for recruiting correct samples. Okay. Is this clear now?
Sir, is there any other method apart from the stratified sampling?
There are many methods. There are many. Okay. Just for example, if I say you have to do a study on State Bank of India in Hyderabad, so there may be 50 branches in, okay, 50 branches or more. But you don't have that much money. So what you can do, you can just select 10 random branches. Okay, random selection of those 10 branches from 50 plus. So you have all names, you just randomly selected 10 branches from this. So this is called cluster sampling. Okay, and then you are doing the study. Okay, so these are the very common one, but the most commonly used is called random sampling and stratified sampling. Because now cluster sampling is not applicable, because even if I do a study on a State Bank of India, I can go to the main branch and I can get all information. Is it or not? Every city has main branch of that bank. Now the same goes for other fields also. So I can go there and I can get information about everyone. So that is why, like, these two are technically 99% time you are going to use random sampling. Stratified sampling will be rest 1%. So it is going to be stratified. Is this clear now?
So, sir, this cluster sampling is also similar to the
No.
stratified sampling. Yes?
It is not stratified. Remember, both are different. Here you have just 10 random branches of this. Here you are stratifying between male and female, stratifying between very poor, lower middle class. So these two are different things. Here you just have 50 plus branches. You just selected 10 random branches. That's it. You're not stratifying based on, for example, if I say I am stratifying something, but based on what? So when we are stratifying something, we are stratifying something based on something. For example, here it is based on male and female. Here it is based on very poor, lower middle class, upper middle class, rich, very rich. So these are the strata, which is clearly defined. So that is why it is stratified sampling, and this is random, and this is cluster sampling. Cluster basically means just having some groups. For example, this is bank 1, bank 2, bank 3, and so on. And then you just selected 10 random branches and you are doing your study. Is it clear now?
Yeah, it's clear. Thank you, sir.
Everyone. Okay. So this is very important, because after this, whatever we are going to learn, if this is wrong, everything is wrong. Okay. Now we will start from the data, because that is the most important thing. That is the most important thing in any field, if it is relying on data. Okay. So what is data? So if I say data, data basically refers observation or measurement. Okay, whatever we are observing or measurement, we are going to look at. Observation or measurement collected from a specific population. That is what data means. It can be number, it can be text, it can be video, it can be audio. When we talk in the sense of data science, when we talk in the sense of statistics, we will see what different types of data are. Okay. How do we collect data? That is the most important. We have seen what should we do to do the data collection, but when we are collecting the data, how to collect it? So that is another very important thing, because when we are in the field, when we are collecting the data, we have to be very sure how to collect it. And what is the process? What is the process of data collection? The basic thing is, when we collect data, so all of these are based on some question which we are going to answer. Okay. So when we collect data, just for example, you are going to do a study to predict car price. Okay. So this is what you are going to do. Okay. You have to predict car price. So when you are going to predict car price, so what is the most important thing? For example, we have to collect data based on this. So we have to decide what we have to collect now. So what should be the first thing? So now I want price. We want to know price. That is the correct answer. This is one thing. How are we going to yes, perfect. This is called brand of the car. Then what? model of the car. Okay, because if I say Toyota have many models. Features, year of the car, basically age, mileage of the car, weight of the car, color of the car. So this is what I am saying. So what happens is when we do any study, we have to come with our data. We have to come with question. Can brand of a car affect car price? Yes or no? Can a brand affect a car price? Can the model of a car affect the car price? Can the year of the car affect the car price? So these type of questions we have to answer. Okay, this is called hypothesis. We have to come with an hypothesis and collect our data accordingly. Okay, so this is the way we collect our data. So this is a very basic example because every field differs. If you are in biology, your question may differ. If you are in economics, your question may differ. If you are in data science, you are going to see something similar. I'm not saying exactly same, but something similar. So this is the way we collect our data. We come with questions. So here I'm giving you 5 examples, but in real life, it can be 250 plus column, because when I was working at Ohio State, so I had more than 300 variables, because in real life when we do the data collection, so it is not that we just go and jump in and do the collection. Okay, we come with many hypotheses. It's not one hypothesis, there will be many hypotheses. Okay, many hypotheses. It can be 100 hypotheses, can be 200, it can be 300. Then we do the data collection, because data collection is a very tedious process. So whenever we have to do it, we just want to be very sure that we don't have to go to the population again within a 6 months or 8 months or 2 years, 3 years. Once we are doing it, we just want to be sure we are done. Next step should be maybe after 6 years, maybe after 7 years, maybe after 10 years. So we go with many hypotheses and then do the data. Okay, is this clear now?
Sir,
Okay,
can you repeat about the hypothesis part? Like I didn't.
Hypothesis is just your question. Hypothesis is nothing. This is just your question. Just for example, how a car brand can affect a car price. How the year of a car can affect the car price. This is your hypothesis. Okay. For example, if I say, can blood group of a person affect the car price? So that is wrong hypothesis. Okay, that is completely wrong hypothesis. So this is what hypothesis means. Basically means you are trying to judge your question if it is going to affect it or not. Just for example, can sugar level affect a person's diabetes status or not? So that is a valid question. But if I say, can someone's car affect the sugar level? That is not a valid question. So this is what your hypothesis means. Is this clear? Everyone.
So, sir, this hypothesis is something that we're going to test later, right?
Yes, this is what we are going to test later. Hypothesis is assumption, but this should be logical. Yes, perfect answer. Hypothesis is based on logical reasoning. So this is what we going to check later on. We are going to create a machine learning model to see if are they going to affect it or not. But before that, we have to be very sure they are affecting it or not. Hypothesis means not affecting something. Basically, yeah, in general, this is what we can say. Okay, if A is going to affect B or not. This is what hypothesis is in general. Okay, is this clear to everyone? Basically, your question only. This is hypothesis, basically means our question, which we are going to judge. Is there anyone who is having any doubt related to this? Okay, perfect. Now we are going to start about we are going to discuss something very important called data. So I have already mentioned data is nothing. It is basically any set of observation or measurement we are going to correct. So let's do a very basic data collection as we have seen earlier. So let's say I have 5 students from this class and I have your ID. So this is DS56 batch and just say 001. So this is one ID, DS56 batch 002, and then so on. So this way I am selecting some information about you guys. So I have 6 students from this class. Now let's go for the name. So for example, I am having, for example, as I said, I just want to be sure males and females. So I just want to be sure like I should be having nearly equal, not equal, but nearly equal males and females. I'm saying Pooja, Saman, then I'm going for Mishra. I'm just using your name, which is written on Zoom. So Chaitanya, then Anil, and just say Sonal. So I have these 6 names. I have to be very sure I should be having nearly equal. Are you guys able to hear me? Okay, perfect. So I am having equal males and females in my data. So this is the first thing we have to be very, very sure. Now let's go and say what is the gender. Then I am going for if you are working or not. So like true or false. Okay. So you are working or not. So I said, just for example, this is hypothetical only. So I don't know about your current status. So I'm just writing some false, true, true. Oh, sorry. And then false. So let's say I have just said it. Now I'm going for your education status. Again, I don't have your information. So I am just going for, like I'm saying, bachelor's. Then I am saying, just say master's. Then bachelor again. Then master, bachelor. Then I have one PhD. Okay. Then I'm going for your stats score. So someone might have been scored 65.2, 62, 75.1, 65, and then 16. So I have these scores. Same, I have Python score. So just say 59, 56, 55, and then 25, 56, and then 30. So I have all of your scores working or not. Again, it is true false. So this is like same thing like occupation. Just say I am having a number of cars because I just want to be sure your current status. Are you from which status are you coming? So it is not directly asking questions. I can ask if the person is having car, it means he's the person is come not poor person or very poor. So number of cars, 1, I'm saying 2, 0, 1, 3, 1. Okay. So I have all of those information. This is like, randomly I'm just creating it just to be, explain what data types are. So this is the way I collected the data. Okay. So this is my data now. But before moving ahead to data or data types, I just want to be sure like how many of you know Google spreadsheet or Excel sheet. Technically, I'm going to use Google spreadsheet, but if you want, you can also use Excel because whatever we are going to discuss is nearly similar. But I will use spreadsheet. So what I'm going to show you how can you get it. So if you see, this is my Gmail account. You must be having something very similar. You go, click here, then click on Sheets. As soon as you click on Sheet, it will show you something like blank spreadsheet. So click on that, and then you will be able to get the sheet. So I will suggest you, let's take a small break here, and then try to open a sheet. because whatever we are going to do, try to understand, or whatever the task we are going to do at a basic level, we will use a spreadsheet to do all of those tasks. Okay, so let's take a small break and then please go and open a spreadsheet or Excel sheet. But I will use a spreadsheet to explain everything. Okay, spreadsheet is good because it is at the end, everything will be saved in your cloud, Google Cloud. Excel may be saved, may not be saved. So just use a spreadsheet as per my request. Otherwise, rest you on you. If you want Excel, you can use Excel. So let's take a break, and when we will come back, we will go ahead with all of these.
Yeah, sure, Sandeep. Okay, guys, let's go for a short 10 minutes break and refresh yourself and come back. And meanwhile, in the break, we have something like our success speaks are there. So just listen it. Okay, so let's take a break.
Currently, I am placed in Swiggy, and my role is basically MIS executive. Basically, I would say I'm very grateful to Odin School because through Odin School only I got the chance to, sit in the interview with Swiggy. So I'm glad that I found Odin School during my career transition path. First of all, thanks to Odin School and thanks to you guys. Next, the Odin School, I think the curriculum of Odin School is very good. Even though I'm from non-IT background, it doesn't make me feel that I don't know anything. It helps me like every step from zero to till now, till this level. Odin has helped me during all the career transition phase. It helps me to learn from the basic to advanced, I would say. Yeah, you have to work on yourself, that's true, but the curriculum they have said, it will help everyone. Like if a person like me who is don't know anything about the IT part or these tools, they can also learn. The curriculum are easy and understandable, that and the instructors are very good. They're the way they explain things are also very good. And before that, I was a very in a government type of role I was working in, so I was not faced with the this kind of curriculum or this kind of corporate thing. But yeah, Odin as like Odin was my first option at that time, and Odin helps me a lot to, from zero to this level. Odin is the something I will be grateful to every time.
So I get a job from ADA, and my current job role is as a data scientist. The good thing about Odin School is, rather than in other platform where they give us like recorded videos, Odin School give live videos. You have a live instructor, so there you can ask them the question, and they will give you the reply. If you have any doubt, then you can also ask them by mail them in success@Odin School. So they reply within 24 hours, and they always call me like if you have any problem or not, if you face this thing or not, explain your project along with your friends. So there it's actually helpful for your communication. It can boost your communication, and you also can see what other people are doing, other how they represent their project, so you can adopt their technique, and also you can see their problem solving skill, like how they solve the problem. They maybe use a different approach, so you also able to learn a new thing in that way.
Right now, I'm working as junior associate BI developer, and I work on technologies like Power BI, Tableau, and ClickSense. And I'm working in several technologies. I think Odin School has played a very important role in last 1.5 year since I came into Odin School. It's even my confidence, whatever confidence I got is from Odin School. They has always been supported me even post getting placed, even after coming to I came to this job and I moved to this new place, Jaipur. I think they were in constant support post even the placement. Even today, if I need something from Odin School, they are ready to give the access to me for anything. So Odin School has, I think, whatever success or whatever I'm enjoying right now, yeah, most of it is because of Odin School.
Okay, students, welcome back from the short break. So I hope everyone are back from the break. Can I get some confirmation in the chat box?
Yes, yes.
Thank you guys. Thank you for your confirmation, and we appreciate your active participation throughout the session. So I request everyone to carry the same energy for the rest of the session. Okay. So Sandeep, over to you.
Sure, Ravi. Thank you. So finally, my webcam is working. So guys, any question before moving ahead? Any question? Any doubt? If you have any question? Okay, perfect. Now let's discuss about the data. So I have already mentioned what is data. Basically, the observations we are going to look at. So that is what data is. There is another very important term which we are going to use is called variable. So what does variable mean? Any guess? Again, guys, I will just. So companies completely depend on it. It completely depends, Shiva. So companies may prefer Excel. Companies may prefer Google Sheet. 99% functions work similarly if you are using Google Sheet or Excel. Okay, they may prefer Python also. So it completely depends. It is good to know. Okay, for example, I am a person who uses Python or R programming a lot. Okay, my Google Sheet or Excel is just like 1% of use. That too just to do quick analysis. Okay, so it completely depends on company to company. But if you know Google spreadsheet, it is very easy to use Excel. If you know Excel, it is very easy to use a spreadsheet. Okay, so what does variable mean? Perfect, someone. So basically means a characteristic, because this is what we discussed: population characteristic or sample characteristics or property which varies from one person to another. Okay, this is what it. This is what in general it means. Characteristics or property which varies from one person to another. That is why it is called variable. Okay, this is why the term is called variable. How does it? How can we see this? So if you go to this data set, so is it not ID is changing from person to person? Is it changing or not? Varying from person to person? If I go for the name, is it varying from person to person? If I go for gender, so someone is female, someone is male, it is varying. Occupation status, it is varying. Education status, it is varying. So that is why this is called variable. Is this point clear? Everyone.
So Sandeep, so can I say my all my variables are out of my hypothesis?
So yes, variables are coming from hypothesis only, but these are called variable because they vary from person to person. Yeah, they are from hypothesis only. Okay. Is this clear? Okay, perfect. So now we are going to discuss about the different types of data. Different types of data. So data in generally is divided into two types. Okay, in two types. That is in generally this is what we say. The first is called qualitative data and second is called quantitative data. Okay, so this is the way data is in generally divided. So can anyone try to differentiate between these? What is the basic difference between qualitative and quantitative data?
So quantitative data is something that can be measured or counted, but qualitative data is something which describes the qualities.
Perfect. So yes, that is the perfectly correct answer. So qualitative data is also known as categorical data. Okay. and quantitative data is also known as numerical data. So that is another the other name. So qualitative data is, as mentioned, it is basically we are talking about quality of a data. Here we are talking about quantity, and we will see what does quantity basically means in general. Quantity of a something. So this is the basic difference between this. We are talking about quality. Just for example, if I open the spreadsheet which I created for you, so if I ask the name, what is this? Is it a quality or quantity? Name. It is the quality. Basically, name basically tells about someone. Gender is the quality. Okay, occupation is your quality. But when I say stats score, then I am talking about numbers. This is called quantity. If I say car, number of cars, then it is quantity. If I say Python score, so this is quantity. So is it clear what is the basic difference between qualitative and quantitative data? Okay, so basically qualitative data is, please mute yourself if you are not asking any question. So qualitative data basically cannot be, basically we are trying to understand the characteristics of something which cannot be measured or counted. Okay, and we will see the difference between these also, what is measured, what is counted, but this is what it means. Okay, these variables can be categorized only. Okay, so that is why it is called categorical. These variables can be categorized only. Just for example, if I say in this the data set I just created for you guys, if I say name, so is it not like we are having specific names here? There can be duplicate names. So that is why we always have some key which is called ID. So these are IDs like a key. Okay, these are IDs like a key. Basically, this represents unique person, but you can have duplicate names. Is it or not? Can we have duplicate names? We can have. So this is your category in general. If I say male, female, is it a category or not? Is it a category? Similarly, if I say education level, bachelor's, master's, PhD, is it a category? So this is what qualitative data is. Qualitative data is nothing. Basically, variables are categorized only. So let's see different types of qualitative data, and it will be more clear after that. So qualitative data is further divided into nominal and ordinal level. Okay. It is further divided into nominal and ordinal level. So let's try to understand the difference between these, and then it will be much more clear. Okay, so when we talk about nominal level data, so nominal level data cannot be ranked. So that is the very important. That cannot be ranked or ordered. So what does it mean? Anyone wants to guess it? What does it mean? This cannot be, yes, names of a person, I cannot rank it. Just for example, if I go here, I cannot say Pooja is better than Samant or Samant is better than Mishra. I cannot say who is better, who is bad. Just using the name. Okay, when I'm saying this, I am just talking about this variable. I'm not talking about anything else. So I am just talking about this variable, and based on this variable, I cannot say. We can arrange Dipanshu, we can definitely arrange alphabetically their name, but we cannot rank them. Okay, we cannot rank. We cannot say, okay, Chaitanya is better than Mishra. Same goes here. Can I say males are better than females? Or can I say females are better than males? Can I say this? I cannot say. So this is what ranked or ordered mean. Can I say, just for example, someone has given the blood group example. Can I say that A positive blood group is better than B positive? We cannot say that. So just for example, fruits. Okay, apple, banana, mango, all of these are fruits only. Can I say apple is better than mango? Or red color is better than? We cannot say based on occupation. We cannot say if someone is, just for example, a lady is not working, a person, a lady is working. So can we say the working lady is better than non-working lady? We cannot say that. We cannot say these things. Okay, but if I say Pooja scored less than Mishra in stats, can I say this now? Pooja scored less than Mishra. But remember, I am not using name here. I am using numbers to do this. I am using numbers to do this. Okay, when I'm comparing it, it is based on number. I cannot just say India is better than USA or US is better than India. It will, if we are comparing based on some number. Okay, so we cannot say this. So this is what nominal level data is. So it is like nominal level data, rank or orders are not possible. Okay, so that is the first thing. We cannot rank them or we cannot have any order. Measurement is not possible. Okay, when we say measurement, we cannot measure it also. So your education degree is not nominal level data, and I will explain in a minute. Okay, we will discuss January that don't worry about that. So there is some confusion here, but just try to understand the example I gave. Gender, just say blood group, race, like Asian, American, Chinese, Japanese. Just using these, we cannot say who is better, who is not. Okay, similarly, go country. We cannot say which country is better, which one is not. We cannot just compare that using the name. So this is what nominal level data, rank or order are not possible. Measurement is cannot be done. So what does it mean is, if I am doing a study and I am saying male is equal to 1 and female is equal to 0. Because this is what happens when you do the analysis, computer is never going to understand what does male means, what does female means. It will understand these numbers. So if I say male minus male equal to 1, does it make sense? So this is what measurements. We cannot do any basic calculation using these. So this is what nominal level data is. So is this point clear? Because there is some confusion with like education level. So I will explain in a minute. So the basic difference between ordinal level data is here order matters. Okay. So this is also an example of qualitative or categorical data, but order matters. Is this point clear? Order is very, very important. For example, education level. So if I go to my data set, if I say bachelor, so is it not bachelor is lesser degree than master? Is it or not? So it means it is a category, but master is higher in comparison to bachelor. Is it not PhD is higher than master? So this is what ordinal level data is. There is an order. There is an order, but we cannot do any calculation based on this. I cannot say, just for example, is education level, okay, or class grade. Class grade is one of the best example. So let's see. Can I say A grade is greater than B? Can I say this?
Yes.
B is greater than C, and C is greater than D, and D is greater than F. So this is very clear. There is a specific order based on the grade. But can I say how much greater? Can we go and check it? How much greater? How much greater A is? from B. Can we get it? There is no idea. If I say A minus B, there is no measurement. So still we cannot do any calculation on this. We know A is greater, we know B is greater, sorry, greater than C, we know C is greater than D, but we don't know the exact value, how much greater is. But if I just say someone scored 99%, just like 99, and another student scored 82, can I figure out now how much? Okay, so this is what measurement means. Basically, I can do basic mathematical calculation, but in the case of ordinal level data, I cannot do any mathematical, I cannot do any calculation. We know this is greater, this is small, but we cannot do any mathematical calculation. Okay, similarly, if I say car speed high, if we have converted everything into categories like high, medium, low. Okay, so it can be used, Mishra. I'm not going for that in that detail. I just want to explain what is basically ordinal level data means. Okay, so D can be like B plus B minus. It can be there. It can definitely be there. But just to make it like a simpler way, I am just trying to explain what does ordinal level data means. Okay, so you might be seeing satisfaction level. Okay, very satisfied, neutral, unsatisfied, very unsatisfied. You might have seen all of those. So still rank and order is possible, but we cannot do any calculation based on that. So is this clear? The basic, what is qualitative data and what is the basic difference between nominal and ordinal level data? So is this point clear to everyone? Is there anyone who is having any doubt? Anyone who is having any doubt with this? Okay. Next comes quantitative data. Basically, we talk about numbers. That is why it is called numerical value. Okay. That is why it is called numerical value. So let's try to understand when we say number, basically means, can we rank them now? Can we rank them? If we are talking about numbers, we can rank them and we can do simple maths also. Okay. When we are talking about quantitative data, we can simply rank them. We can do simple maths. The quantitative data is further divided into something called discrete and continuous. Okay. So discrete values and continuous values. So this is the way quantitative or numerical values are divided. Okay. So now let's see what is the basic difference between discrete level data and continuous data. Okay. So discrete data is, there is a number, we can do mathematics, but discrete basically means what we are doing, we are trying to count something. Okay. Here we are counting something. When it comes to continuous data, we are trying to measure something. Okay. Counting is, if I say, just for example, if I go to this and I say number of cars. So am I measuring it or am I counting it? I am counting it. Okay. And if I say your stats score, am I measuring it or am I counting it? I am measuring it. So that is the first fundamental difference between them. We are counting something in discrete data and we are measuring something into continuous data. Another very important difference is intermediate values are not possible. And in this case, intermediate values are possible. Okay, so this is another very important difference. But just for example, let's say the data set we have created. If I say Pooja has 1.5 cars, is it possible? No. But if I say Pooja scored 65.2, is it possible? So that is another fundamental difference between this. So when I'm saying it, intermediate values are not possible. So the example is, we cannot have values in between. Basically, no decimal values. Decimal values not possible. In generally, this is what we say. Okay. For example, is IFSI number of cars. We cannot have 1.5 cars. If I say, if you go to your neighborhood and you are looking for how many kids everyone has in that. So is it a count or is it a measure? Number of kids. Is it a count? Perfect. Why? Because we are counting them. Second thing is decimal values are not possible. But if I say you are doing a study on height of a school, okay, height of a school. So student 1 height is 183 centimeter. Student 2 height is 184 centimeter. So the first thing, are we measuring it or not? We are measuring it. That is very clear. Now you tell me, intermediate values are possible between these two values? If we change, go down, definitely someone can be 183.5 centimeter. If I go more beyond, I can say like someone can be 183.55 centimeter. Is it possible? And I can also say, okay, someone is 183.555 centimeter. If I have that great measurement, I can definitely go beyond that too. So this is what continuous data is. Continuous data is always we are trying to measure something. It's always when we intermediate values are always possible. Okay, we can have intervalues, just intermediate. For example, if I say even in this, if I say you have 183.5556 centimeter, can we have values between these two? Can we have or not? We can still have values between these. So this is what intermediate values are possible. This is what it means. So this is the fundamental difference between discrete and continuous data. Is this clear to everyone? What is the basic difference between discrete and continuous data? Anyone who is having any doubt? Now you tell me, height of people, is it discrete or continuous? I am going to ask 3-4 questions. You just answer me accordingly. Height, discrete or continuous?
Continuous.
Continuous. If I say number of
Continuous.
people in a mall, is it a discrete or continuous?
Discrete.
Discrete.
Discrete. Number of pregnancy.
Discrete.
Discrete. Discrete.
Discrete. If I say age of a person.
Discrete.
Discrete.
How age is discrete? If I say someone is 24 years old, so is it the person is exactly 24?
It's continuous, sir.
Is continuous. Just be sure. Technically, what happens is when we enter the value, we are always going to write 23, 24. But the person is exactly not at the same age. We are just rounding it off. The person may be 23 years, 5 months, 8 days, 7 hours, 15 minutes, 22 seconds. So the person age is like that. Okay. So this may be like, so that's why it is a continuous data.
So,
So, sir, I have a question.
Can
Yes.
age comes
So,
under ordinal data?
age is not an ordinal. Can I, just for example, can we do mathematics? If I say someone is 25 years old and someone is 10 years old, can we do maths? Can I say the person second is 10 years, like 15 years younger? Can I say this or not? If I say is a student one's age is 25, the student 2 age is 29. So can I say that student 2 is 4 years older than student 1? Can I say this? So it means we can do math. It is first thing is it is number. If it is number, it cannot be not, qualitative data. That is the first thing. That is that now it comes to quantitative data. That is the first thing. Once we are sure that this is number, now we have to check if it is discrete or continuous. If it is discrete or continuous. So first thing, we are measuring it. We measure the age. Okay. Because why we am talking about the data type, because all of your analysis completely depends on the data type. All of your graphs completely depends on the data type. When you are dealing with qualitative data, your graphs will be different. When you are dealing with quantitative data, your graphs will be different. When you are dealing with qualitative data, your statistical analysis will be different. Just for example, can you calculate average for males and females? Can we calculate it? What is the average of males and females? Can we do that? We cannot do that. Perfect answer. So we cannot do that. But can we say what is the average age of this class? Can we say this? So this is why it is very, very important to be sure that what type of data is. Okay. So is it clear now, the age issue? Because some students have mentioned it's a discrete data. So is it clear now?
Regarding age categorizing as continuous data, I have something.
Yes.
Let's say I am interested in only years, like age of person in years. So can I say that is as a discrete data? I mean,
Again, you are trying to measure it or you are trying to count it?
um, here, yeah. So yeah, then if I am, yeah, it's like I want to see the number of members who are like between 25 and 26 years.
So who are between, remember that when you are doing it, then you are going to count the numbers. It doesn't matter anything, like if as a question it matters 25 and 26 years, but you are counting it now. So when you are counting it, so it will be like 25 years, there are 52 people of 25 years and there are 23 people are in 29 years. So then this is count, but this is not. Okay. This is still your continuous data, but this is count.
Okay, but my column value says, let's say my column value says age in years. Then
okay, so age in years, as soon as you write age in years, it becomes measurement. Remember, when we measure something, it is always also going to have unit at the end. When we count something, there will be no unit. Is this point clear? When I'm saying 52, this is just number. But when I'm saying 25, so it is years. So there is a measurement here.
I'm still confused. Thing is, say
Okay, so let's say you have age in years. Okay, first thing, as soon as you say years, it is without any doubt this becomes continuous data because you are measuring it. Okay, here you are measuring it because as soon as you say years, now you tell me how are you going to get the counts in this column. You will be something like this: 23, 24, 29, 32, something like this or not?
yes.
21. So again, you just having values here. There's no count in this. You are just having some values which basically represents age of these students.
Okay.
Okay.
Couple of minutes.
Rest comes your descriptive statistics where you want to see how many students are of 24 years of old. Then you are see, okay, There are 8 students who are 24 years old. This is your count, but this is your measurement.
Okay. I mean,
Okay.
this is good, but if I say my age is whole number, right? In years, if I'm giving in years,
Yes.
this is my whole number.
Technically try to understand one point. Whenever we do analysis, no one goes for analysis anymore for 23 years, 8 months. Everyone is just doing the with whole number. They are not doing with 24 years, 4 months or something. Until unless it is related to kids.
Okay.
Okay. So it is always done with the whole number. If it is related to kids, then we go for months or days.
So, but we can also say that we are counting the age in years. Maybe that is what.
How do we count age? We are measuring the age because it has a unit. Okay. It has a unit. Whenever you have a unit,
What I'm
basically
trying
you
to convey is we cannot count the age as such, but we can count the age in years, right?
in a basic way we can say that, in a statistical way we are measuring the age. In general we can say, for example, when we say okay, we are counting the money, is it or not? Okay.
Yeah.
Just for example, salary. So let's go for this example. This may help you to understand it better. So if I say salary, is a discrete or is a continuous?
Discrete.
Again,
No, it's continuous.
it is continuous. Yes, it is continuous. Why? Because what happens is many a times we think in the perspective of India, where we are not using any paisa. But if you just see the US dollar, they have decimal values. If you go to Denmark, their Danish krona, they have decimal value. Okay. Even if when you pay, go and do the Google Pay. Have you seen like many a times you just get decimal values? Is it or not? Is it or not? Have you seen this? So salary is also a continuous data, but many a times we are counting it. We don't count salary. We count number of notes. Is it or not? If it is a 500 rupees notes, we just see how many 500s are there. And then we calculate what is the total money. When we say total money, it becomes continuous. When we are counting the number of notes, then it is a count. It is a discrete. There are 50 500 notes. So this 50 is your count. This 500 rupees is your continuous data. Okay. Is this
So
point clear now?
we can say like continuous is with respect to time. Like anything changing with time is continuous, right? I mean, age is with time and.
Age is a continuous. It's not based on the time. Just for example, if you go and buy 2 kilogram of rice, okay, will it change based on time?
No,
Not
it doesn't
necessary.
change. No,
It will not technically, yes. If you have bought it, definitely you will cook and eat it. It will be gone. But in generally, is it a discrete or is it a continuous?
It's still a continuous one.
It is continuous because
Because
the first thing
it
is
has unit.
we are measuring it. We are
Measure.
measuring the weight of rice. Same goes, we are measuring the age of a person. When we say 23 years old, we are measuring it. We are not counting it. In general, there's two things. One is layman, one is statistician. Okay. So for layman, in generally we say we are counting the age. That is layman perspective. But as a statistician or in the field of data science, our perspective differs. That is the difference. Is it or not? That is the difference between a data scientist and a layman. Discrete data is always going to be whole number. You cannot have intermediate values. Okay, so that is the most important thing. So whenever you are dealing with discrete data, you are always counting it, and intermediate values are not possible in any case. Okay, so this is what discrete data is, because even if you put it, it is not going to make sense. Continuous data is always we are measuring it, and intermediate values are always possible. Even if we put it, if we don't put it, doesn't matter. For example, if I round off all of these values, for example, I have student's height in centimeters, and that is in decimal. Even if I remove the decimal values, it will not become discrete. It will always be continuous. The same goes for age. Even if we are removing months and everything, but it is again, technically we just rounded it off. It is nothing else. Like, for example, like if someone's weight is, just for example, if someone's weight is just go for 78.65 kg, and I just rounded it off, it became 77 kg. Okay, so now is it discrete or is it continuous?
Still,
How are we going to judge it?
it is continuous.
It is continuous. It doesn't matter if it has decimal or not. It doesn't matter. We can still have decimal values. If we want, we can still have decimal values. But again, another important thing is unit. If we have unit, it means we are measuring. If we have unit, we are measuring it. Okay, so whenever you see a data point, first see if it has a unit or not. If it has unit, we are measuring. Then see, can we have decimal values or not? We can still have. We are rounding it off, doesn't matter. But we can still have decimal values. Same goes for age. Someone may be 24 years, 8 months. But as per statisticians, what they do, they will not say the 8 months, so it will become 25. So the person is still 24 years. It is just rounding it off, nothing else. So it's still the first thing we have. Do we have units or not? We have. So, and then can we have decimal values? Definitely we have. So that is why it is continuous. Is it clear now?
Yes, sir. Sir, one more thing, like before you said like ordinal values are no, age is not an ordinal data. It is quantity data, right?
Yes.
So, but in the example which you gave before, like in ordinal data, you said car speed is also comes under ordinal data.
Yes. When I said car speed, so try to understand car speed is high, medium, low. Okay. So do you think high, medium, low is a number? Just try to think. Is it a number? Is it a category? Okay. If I say car speed is 85 kilometers per hour,
yeah,
then it is a number. If I'm saying car speed is high, then it is a category.
Achha, okay, okay.
Okay. Is it clear now?
Okay.
So is it clear? The four data types: nominal, ordinal, discrete, and continuous.
So, sir, most of the time we will be dealing with the quantitative data, right?
Not necessary. It completely depends on field. It completely depends on where are you working. You never know what type of data is it going to be.
Okay.
Okay. So we have to know all of these types.
Hello, sir.
Yes.
So can you please explain about like difference between count and measure?
So if I say, just if you remember, if I say, just for example, you have two dogs in your house. So are we counting or are we measuring? Two dogs in your home.
Counting.
You're counting. But if I say you bought 50 kilogram of rice, so are you counting or are you measuring now?
Measuring.
Measuring.
So this is the basic difference. If I say your dog is 3 years old, so are you counting or you are measuring its age?
Counting.
It is not counting, it is measuring. That is the basic difference between a layman and a statistician.
Sir, while comparing the age, like one is elder, one is younger, how can
Yes.
we categorize that thing?
How?
While comparing the ages of the persons, how
That is
can we
category.
When I'm comparing the age of a person,
yeah,
so we can simply do the math.
like how can we take that like count or measure?
It is a measure. The person is, for example, if I say 25, 29, so I will I just say 4 or I will say 4 years old, elder? What will say?
How can we take
What will
that
I say?
data in that?
Hmm?
How can we take that data like ordinal or continuous? We cannot get that.
So remember, okay, okay. Number one, can we have numbers in ordinal level data? This is the first thing. Can we have numbers? We cannot have numbers. That is the first thing.
Okay.
So if it is a number, then it cannot be ordinal level data. Ordinal level data is always like, okay, grade, ABCD, car speed, high, medium, low, education level, bachelor's, master's, PhD. You can never have number, but you can have order. Are you getting this now? For example, here, this is your ordinal level data. You have categories only, but these are your numbers. That is the difference. We can say master's is greater than bachelor, but how much? I don't know. I cannot do any mathematics. Is this point clear now? When it is nominal and ordinal level data, you can never have numbers. Is this point clear to everyone? When we are dealing with nominal and ordinal level data, we cannot have numbers there. When we are dealing with this quantitative data, we are always going to have numbers. So that is why if you see, when I mentioned this, qualitative data, categorical data, quantitative data, numerical data, basically numbers. Is this point clear now or any doubt?
Clear, sir, clear. We understood.
Okay, perfect. So when we talk about when we are, yes, we are measuring it, younger, older, we are measuring it. And someone was mentioned about the car speed, 58 kilometer per hour. So it can be 58.5 kilometer per hour also. It can be 58.9 kilometer per hour also. So that is a continuous data. It is not a discrete data. Okay. Another thing is continuous data is further divided into two parts. One is called interval level data. Another is called ratio level data. Okay. So, but the thing is, we should know the difference, but technically they do not do much change in the analysis. Graphs or anything is not going to change. But we should know the basic difference between interval level data. Okay. So when we say interval, so what does it mean? Interval basically means interval, the difference between values are meaningful. So this is the first thing, difference between values are meaningful. Okay. So this is another very important thing. That is most important. Difference between values are meaningful. Second very important thing is no to zero. When we talk about ratio level data, very important thing is true zero is possible when we say ratio level. So I will explain what does it mean. True zero is possible when we are talking about ratio level data. Okay. Second important thing about ratio level data is it also has equal intervals. Okay, it also has equal intervals. So just try to understand the difference. Difference between values are meaningful. Just if I say temperature in Celsius, okay. If I say 20 degrees Celsius and 30 degrees Celsius, 30 degrees Celsius and 40 degrees Celsius. So is it not the values are having some meaning? They are equal, 20 and 30 degrees Celsius. And then comes and 30 and 40 degrees Celsius. Okay, so if I say these, so is it not like they are meaningful? It is same difference between them. Difference between 20 degrees Celsius and 30 degrees Celsius is same as 30 and 40. Is it same or not? Everyone. But if if I say 0 degrees Celsius, so does it mean there is no temperature at all? Everyone, 0 degree. So this is what that mean. No true zero means. even if we are saying 0, but there is some temperature left. Is it or not?
It can be in minus also, right?
It can be minus also. The another basically thing is interval data can be in minus also. Ratio level data cannot be in minus. Okay, so this is another important thing. So 0 basically, well, this is what it means. If I say 0, if I go back and say 0 years, it doesn't mean that there is no year. If I say 0 years, if I say 0 years, if we go to, after Christ, before Christ, there will be some year. So can we say 0 years is no years? So this is what interval data is. But if I go for ratio level data, okay, to 0, if I say weight is 0 kilogram, so can I say there is no weight? Can I say this? Everyone, please unmute yourself if you are not asking anything. Okay. If I say 0 centimeter height, can I say there is no height? Okay. Please mute yourself if you are not asking any question. It is resolving the class. Okay, so we can say that. But if I say, just for example, in this one, we cannot do basic mathematics when we are dealing with interval level data, specifically multiplication or division. So can I say, basically should make meaning. If I say 10 degrees Celsius, okay, if it is 10 degrees Celsius and if it is 20 degrees Celsius, can I say this 20 degrees Celsius is 2 times hotter than 10 degrees Celsius? Can I say this? Everyone, we cannot say this. I can say 20 degree is 2 times more, but I cannot say it is 2 times hotter. Are you getting this point? But if I say here, if I go for a ratio, if I say 5 kilogram weight and 10 kilogram weight, here I can say this, yes, 10 kilogram is twice of 5 kilogram. Weight is twice of 5 kilogram. But here because we remember what we are trying to measure with this, we are trying to measure the temperature. Yes, you can, definitely, that is perfect answer, Sati. We can say 20 degree is 10 degree hotter, but we cannot say it is double. Okay, just try to understand. We can simply do the addition and multiplication, but we cannot do, sorry, addition and subtraction. We cannot do multiplication and division. So that
Can you please explain why we cannot say that it's 2 times hotter? Like it will feel definitely 2 times hotter if it's.
it will feel hotter, but not necessarily 2 times hotter. Have you seen like sometimes people say the temperature is 40 degrees Celsius, but it feels like 44? Is
Yeah,
it?
sometimes that happens. Yeah.
It's not sometimes, it is going to be because temperature depends on many other things. So we can
Why
say
they are
this
calling like
20,
that?
20 degree is 10 times more than 10, but we cannot say it is 2 times hotter. But in case of weight, we can say that. In case of height, we can say that. It is not only 5 degree, it is basically twice. The weight is twice of this. So addition, subtraction is possible, but multiplication and division is not possible in case of interval data. But when it comes to ratio level data, basically in the case of in meaningful cases, it cannot possible. But when it comes to ratio level data, so Abhishek, so you feel like if I say, just for example, 5 degrees Celsius temperature and 30 degrees Celsius temperature. Okay, so you will say 5 degree is 6 times lesser hotter than lesser hotter than 30 degree. So example is in years. If when we talk about years, okay. So if I say Just for example, if I go for the years, if I say today is 2025 and 2000, if I go and check it, so it is 25-year difference. Is it or not? But can I do any type of multiplication and see it is 200, like 50, 1.5 years more, or it is 10 years more? If, say, just for example, if that year is 100 years, 100 years, and then it is 200 years. So there is a difference between 100 years, but we cannot say 200 years is basically the year 1000 and 2000. We cannot say this, 2000 is 2 times more than 1000. Can I say this? I can say there is a difference of 1000 years, but I cannot say that 2000 is, 2 times more than 1000. Are you getting this point now? Okay, so this is the basic difference between ratio and interval level data. If it is not clear, the fundamental difference is 0. 0 is going to make sense if it is a ratio level data. 0 will not make sense if it is the interval level.
The same wise age also varying from person to person. If 5 years and 10 years.
This is the calendar year, that is age year.
No. One person is 5 years, another person is 10 years.
Can we not say? Try to understand. Because
Like this, we
remember,
cannot say I am double than you.
so first thing is 0 possible in this case? If I say years calendar year, is 0 a possible value?
No.
Not at all. If I say age, let's say age of a person, not a calendar, is 0 a possible value?
No.
So if someone is less than 1 year old, so can we not say the person is 0 years?
Yes.
We are definitely going to measure in months, but we can definitely say that 0 years. What does it mean is, if I say the person is 0 years, does it make sense or not? Can person be negative? Like -1 years, -2
Doesn't
years?
mean
No.
Not possible. But
not
here, if you
possible.
just see the year, like when you talk about before Christ, after Christ, we still have before 0 and after 0. Is it or not?
Yes.
Okay. Okay. So then this 0 doesn't make sense. But here 0 makes sense. If someone is 0, basically it means the person is not even 1 year old. This is it. Does it mean or not? We never say, Abhishek, we use months. That's what I'm saying. When it comes to kids, we use months, we use days. But when if someone is 0, it means the person is not even 1 year old. Same goes. Can we say a person is 0 kilogram weight? Not a possible value. But what does it mean is 0 is possible value. 0 is a possible value. When we say 0 means, basically means we say 0 means no weight. 0 means here 0 means no year. This is what it means. We will never use, okay, the person kid is 0 years old. But 0 basically means no year. Basically, the kid is not even 1 year old. This is what it means. But when I say 0 years in the case of calendar, can we say this is 0 years basically means not even a single year started? Can I say this? Just try to understand. In this one, can I say this 0 years basically means not even a single year started in the case of interval data? But in this case, can I say this not even the first year started? When I'm talking about age of a person, can I say this? The kid is not even 1 year old.
Yes, we can say that.
But if in this case, can I say this? The calendar is not even 1 year.
Probably no.
We cannot say. So that is the basic difference. 0 basically means it has meaning. Here, zero has no meaning, but here it has some meaning. This is the basic difference. Is this clear now?
Yes, clear.
Everyone. Okay, perfect. So let's take a small break and then we will go ahead with and try to see some basic, measures of, these numerical measures like what is mean, what is median, what is mode. We will try to see.
Yes, Sandeep, sure. Yeah, okay, guys, let's go for a short 10 minutes break and we'll continue the session after the break. Okay, students, welcome back from the short break. So I hope everyone are back from the break. Okay, okay. So okay, Sandeep, over to you.
Sure. So guys, let's go and try to understand few other things. And before moving ahead, so I just want to be sure if everything is clear, any question, any doubt. Again, I'm saying like you are learning many things today only, so it may take some time to get everything, but at a basic level, whatever we have discussed, is it clear or any doubt?
Yeah, yes, I'm the guy only know the data types of number, text, and dates. But here, in number of data types I have, I'm seeing it
No,
first time.
this is the way statistics we do. When you go ahead, you will see text data, you will see image, image, you will see video, all of these are there. Okay, you will see all of those as you go ahead, but in statistics, this is the way we see the data. So again, data is divided into two types. One is called qualitative, basically categorical data. We are dividing our data into categories. Okay, and another is called quantitative data, basically numbers. When we say categorical data, you cannot do any math. You cannot say bachelor's is 3 years more than master's or whatever is there. You cannot say male is greater than. When it comes to nominal and ordinal level data, basic maths is not possible in both scenarios. But in nominal level data, we cannot have rank or order. We cannot say male is greater than female. We cannot say red color is better than black color. We cannot say, apple is better fruit than mango. We cannot say these things. There is no way we can rank them. But when it comes to ordinal level data, we can rank them. Just like education level, we know PhD is higher degree than masters and bachelors. We know that professorship is higher level than associate and assistant professor. We know these things. That is higher rank. We know the CEO is a higher rank than COO. We know these things. So there is a rank, but we cannot do any calculation over there. Next comes quantitative data. Quantitative data, basically we can do this number. That is why it is called numerical level. We can rank them. We can do basic math. It is further divided into discrete and continuous. Discrete is when we are counting something. There will be no unit. Okay, we are not measuring, we are counting, and intermediate values are not possible. Basically, if you put intermediate value, they are not going to make any sense. It's just like number of cars, number of kids in a family. Okay, number of people in a mall, number of cars in a showroom. All of these, number of COVID cases in a day. So they are count. Basically, when you say count, you are just going to see the number. Continuous data, we are measuring something, intermediate values are possible. Even if we are rounding it off, it is always going to be, we can always put intermediate values. Then comes ratio and interval level data. The basic difference is, the basic is in interval data, no true zero. Zero is there, but it has no meaning. It has no meaning. When it is a ratio level data, 2 0 is there, basically 0 is there, it has meaning. And if it is like still confusing, then only one thing is you cannot have negative values in ratio level data. You can still have negative values in the interval. So 0 basically means things are there, but it doesn't make sense. Ratio means 0 is there, it makes sense. You can do simple addition and subtraction in interval level data, but you cannot do multiplication. Multiplication basically means multiplication is not going to make sense. But in ratio level data, it is. That is the fundamental difference between different data types. So again, after the session, you can try to revise more. Anything you can ask me tomorrow also. And you can send us an email and you can also reply accordingly. So these are the different data types. Next comes, what are we going to do with this? Is it or not? We know the data types. What are we going to do with it? So that is called numerical measures. Okay. Basically, we are trying to get the summary statistics. Summary statistics or describing the data. Okay, that is why it is also called descriptive statistics. We are just trying to describe the data. Just for example, in this class, I have 100 students. Just for example, I have 100 students. And now I want to see how good are you in maths. And I have to explain it. So do you think it is possible for me to go and explain everyone's number? Okay, student 1 has scored this much, student 2 has scored this much, student 3 has scored this much. Does it make practical sense? What can I do in that scenario? Because this is a small number. But when you are dealing with big data, then there will be 1 lakh, 2 lakh, 5 lakh, 10 lakh people. So what we try to do, we try to summarize it. So that is why it is called summary statistics. We try to summarize the data. Okay. Or we try, and when we are summarizing it, we are also trying to describe the value. For example, the average Python score of this class is this. Okay. Median Python score of this class is this. So this is what it means. So when we do numerical measures, there are fundamentally two ways to do it. First, we will start with measures of central tendency. Another is called measures of dispersion. First, we will discuss what is central tendency, and then we will discuss about measures of dispersion. So central tendency basically means how your data is centered. This is why it is called central tendency. How your data is centered. So there are three different ways to check it. One is called mean or average. Another is called median, or third is called mean. So these are three ways to figure out how your data is centered. So if I say I have some values from this class, 25, 27, 29, 31, 30. I got your Python scores. Now these are the values. Can you tell me, because this is very simple mathematics, what is the average value or mean value? Or how do we calculate it? How do we calculate average?
Sum by total, overall
Yes.
20.
The first step one is add all values, and step two is then divide it by number of observed. Okay, so this is what basically means. In statistics, we write it like this. We say summation, we use summation symbol. This symbol is called summation. It means we are trying to add everything. When we add everything, we use summation symbol. Summation of xi. Xi basically means these values, this value plus this value plus this value. That is why it is called I. Okay. And then divided by number of observations. So this is the way we calculate average. Summation of all of those values divided by n. Okay. So this is the way we calculate average. So can you tell me what is the average of this?
29.
So average is simple 29. So that is why I use a simple value. And now we will see how can we do this into a spreadsheet. So it's very simple. Can anyone guide me?
Just AV.
Yes, perfect. You don't have already giving me some, but because we are calculating, so as soon as you start writing, so we are going to average from F2 to F7. So if you see, it is automatically deducted. So the average value is basically your mean value is 68.0. We can simply do that, and we can get this value, which is simply, let me copy this. So we can simply use average. Remember, one of the most important thing when you are dealing with is using equal symbol. If I don't use equal symbol, it will go wrong. Okay. And second thing is you have to be sure which column we are going to. Okay. So here I am using F2 to F7, so that is why we are doing it. Otherwise, whatever the column we are using, it completely depends on. Okay. So is it clear what is mean and how to calculate using Excel? So Excel or spreadsheet. Okay. Another very important thing is, here it is a small data set, but in real life we don't know how many rows we are going to have. Technically, whenever we get data, people explain everything, how many observations we have. So when you are dealing with a spreadsheet, so you have to understand few things. So let me explain about Excel sheet or spreadsheet. So these are known as your variable or column. Okay. So these are your variable or column. And these are known as your observations or rows. So these are your observations and rows. So these are technical terms we basically use when we are dealing with data. So number of observations, how many observations do we have? How many variables or column do we have? So all of these. In machine learning, we start calling column as features. In machine learning, rather than column, we say features. That is the basic difference between. And when we talk about spreadsheet is again, it's very simple. If you see, it is very similar to Excel and Microsoft Word also, like not in the context of spreadsheet, basically the tab. So if you want to open any previous file, you can click on open or import. For example, if you have an Excel sheet, I will share it with you tomorrow, or I will try to share it with today only. You can click on import, and then you can just go to upload, and you can browse it from your system. This is the same thing you may have seen in Excel. Basically, you can get an Excel sheet from your system. And then comes to edit. If you want to undo something, redo something, if you want to cut, copy, then comes to view. So this is called freeze. So what do you want to freeze? You want to freeze rows or columns? Mostly we prefer columns. I'm saying first column. Now, if you see if it is freeze, I can do the change. I can go accordingly and I can check it. So this is called basically freeze. Okay, so we can do the freezing also. So all of these you must have learned during, at least at a basic level, you must have seen during Excel also. Okay, and as we go ahead, we will see some basic functions, how to use and how to do the calculation. So the first thing is it clear what is mean? Okay, I was going to tell something important, I forgot. So if I say I want to see how many observations do I have, so there's a function called count A, and then you just have to give the observation whichever. For example, I say A colon A, and if I enter it, it tells me I have 7 observations. Is it or not? So I'm just sharing this with you. You can also try this. Count A. So you can use any column, but you don't have to give numbers. So this will tell you how many observations do you have in your data set. So let's share this with you guys. You can also try this. I can use AA, I can use AB, I'm sorry, BB, I can use CC, whatever I want, I can do that. So this way, I will know how many observations do I have. But one interesting thing is, is it giving me number of observations, or is it also adding the column names?
Adding the column name also.
So how many observations do we have now?
Actually, we have 6, but it gives us column name.
7. So this is where we have to be cautious. Okay. So it will give you in everything, including column name. So there we have to be cautious. Okay. But this is the way. If you have a huge data set and you cannot go back, explore everything, you can simply use this function and you can figure it out. Okay. How many observations do you? So is this clear now? It is not clear, Nazia? So what is mean? How to calculate it? So this is just to know how many observations do you have, how many rows you have. A is basically this is the function created. A basically means I'm using a column. So it is going through all of these and then trying to see how many values we have entered. It is going for all of these. It is going till bottom. If I just scroll it, it is going till bottom. Okay. What it is doing is it is just checking how many cells are filled. This is what it is doing.
Sir, you are saying that mean represents the complete column.
Center. No, mean represents the center of the data. This is your mean here. So it is
Do
at
we
the
take
center.
decisions by seeing the mean of the data?
No, we can summarize it, not decisions. Okay. For example, rather than going and telling for everyone in the class, I can just say, okay, this is the mean of the class. For example, if when I calculated it, so here I'm just having 6 observations, but in real life, I may have 600 observations. So I cannot go for everyone. I will say Pooja scored 65.2, Samant scored 62, Mishra scored 75.1, Chaitanya scored 65. What I can say is the average score of this class is 60.05. Is it clear now?
Okay.
Okay, this is called summarizing the data. Okay, I cannot go and explain everyone's value in real life. So you can just imagine you have 1 lakh data and you have to present it in a meeting in 10 minutes. How can you present it?
Okay. Okay,
We
sir.
cannot present go and 1 lakh and say everyone's score. That is not even going to make sense. So we will just explain these values. Okay.
Okay.
Another very important thing is called median. So just for example, if I say I have these values 1, 2, 3, 4, and 5. So can you tell me what is the mean of this? What is the mean value of 1, 2, 3, 4, 5?
3.
3. So can we say mean is somewhere between? Can we say this?
Yes.
But now if I say I have values 1, 2, 3. Yes, yes, Rajit, that is perfect. 3, 4, 9. Now you tell me what is the mean value?
Twenty.
20.
20. So I'm seeing like many of you. Okay, so it is 20. Mean is 20. If you calculate, everything is 100. 100 divided by 5 equal to 20. Okay. So now you tell me, do you think 20 is somewhere center of this data?
No.
Everyone?
No.
No. So where is it lying? It is lying somewhere here. It is not at the center of the data. Now my question is, do you think mean is a good way to calculate when you have data types like this, when you have values like this?
We should be going with the median.
Yes, that's why going to discuss what is median. So when your data has outliers, so this is what outlier means, basically extreme values. If you see 90 is outlier here.
Yes.
So 90 is outlier. Outlier is nothing, they are called extreme values. So what does it mean is they are far away from the most of the data points. Okay. They are far away from the most of the data points. So what they do is they drastically change the mean of the data. If they are changing the mean of the data, then mean is not a good way to find it. Okay. Then mean is not a good way to work on. So in that scenario, what we do, we try to calculate median value. Okay, we don't go for mean, we try to calculate median value if you have outliers in your data. So is this point clear? Everyone, please let me know if this is clear. We cannot use mean if we have outliers. Outliers are nothing, they are extreme values in our data set. So what should we do in this scenario? We try to calculate something called median value. Median is nothing, median is called middle most value. Okay, this is called middle most value. So Akhil, outliers are nothing, they are extreme values. In this data set, if you see, this is your outlier. Why? Because most of the data points are close to each other, but this is quite away from them. So if you go here, so let me share the data. Okay, so just for example, I have so many students 23, 24, 29, 32, 21, 25. They are close to each other, just for example, but I say this student is 45 now. So is it not, it is far away from the other data points? If I just say a student 6 based on the ID, it is far away from the other data points.
Yes, he
So
is.
this is what outliers means. They are not coming from the, they are actually not representing the whole population. They are little bit away from the population. So this is what outliers mean. So just for example, I am doing a study. I have 99 males. Yes, 45 is outlier because this is not coming from the group. So 45 is outlier. If I say I am having weight data, okay, so I have weight 68, 75, 65, then 82, and then 105. So suddenly these data points are close to each other, but this is quite away from them. 105 will become outlier. Okay, so this is extreme data, which is not from the other samples. It is quite away from the sample. So that is what outlier is. Is it clear now?
Yes.
Okay. So in median, what we try to do is we have to, even we cannot calculate mean in this scenario. We have to find another way. So statisticians, what they did. So in this scenario, let's try to figure out another way. So it is basically middlemost value. So here I am having the data set like this. So can I say 65 is the middlemost value?
No.
So the step one is we have to arrange the value in ascending order. So 65 is the smallest value. Then we have 68. Then we have 75. Then we have 82. And then we have 10. So the step one is arrange the values in ascending order. Okay. Technically, when you will use Excel sheet or spreadsheet or if you are coding, you don't have to do anything. They will take care of everything. Arrange values in ascending order. Okay. Then step two is find. Please mute yourself. It's like you're disturbing my concentration. So if you're not asking, please keep yourself in mute. Find middlemost value. Okay. Next step is to find middlemost value. So how can we do that? It's very simple. What we have to do here is what I have to do here is simple. I will do one thing. I will use a basic mathematical formula that is called n plus 1 divided by. So how many observations do I have? How many observations do I have here?
5.
5. So 5 plus 1 divided by, this will give me
3.
3. So basically, what does it mean? It doesn't mean my median is not 3. This is telling me at third position, my median is lying at third position. This is what it tells me. At third position, middlemost value is. Now you tell me what is the middlemost value.
75.
75.
Why? Because this is number 1, this is 2, this is 3. So this is your middlemost value. So that is why this is what median is called. Okay. Median is your 75 in this scenario. So is it clear how to calculate median value? And what does median means?
Sir, what if we have 4 observations?
Okay, so that was the expected question. We will go for that in a minute. But this is what I would do. So is it clear what is the fundamental difference between
Yeah.
what is the fundamental difference between mean and median? When to, because remember, it is you can calculate everything, but you have to be sure what to calculate. So what does it mean is if I say
That is, mean is sensitive to outliers, right, sir?
Perfect. Mean is sensitive to outliers. So when you have outliers, now my question is, if you have outliers, what will you use, mean or median?
Median.
Everyone, median. Okay, this is very, very important. Otherwise, your whole analysis go wrong. No outlier, then
We can go with mean.
yes, always go with mean. But interestingly, if you have no outlier, mean and median will be close to each other. But still, we use mean only. Okay, this is very important thing. If you have no outlier, mean and median will be close to each other, but we always use mean.
So
Okay.
I have something.
Yes.
Like if my data set is having more number of outliers, so will my median, will my statistic?
No, it is, remember, when we are doing it, so it is not doing any mathematics. It is just looking, arranging the data in an order and looking for the middlemost value. It is
Okay.
not doing anything.
So
Okay. So
um,
it is just looking for whatever is the middlemost value is.
so let's say 65, 68, 75, 82, 105 is like my speed of a car, right? Okay. Uh,
Yes.
let's say now I have a data set for 1,000 members.
Yes.
Okay, and first 50 are ranging between speed of 10 to 30,
Okay.
and my other speeds are like ranging between 150 to 250. So if I say this whole data set average speed, if someone asks me what is the average speed of this particular data set, so how
So
do
you have to calculate it. Remember, you said 150 till 200,
hmm,
rest of the 30, rest of the data set.
hmm,
Okay. So what is happening in this scenario? Again, you have to arrange it. Okay.
hmm,
Again, you just have to arrange like this,
hmm.
and whatever the middlemost value is, that is your median.
Yes, I got it. So
Yeah.
if someone asks me what is the speed limit that should I be setting so that everybody falls under some particular speed, so this can I consider this 150 200 as outliers?
No, in this scenario, this is your one population, because if
uh,
the car speed is this and car speed is this, basically they are two different population.
okay.
Okay. So that is, as you go ahead, you will learn all of those, because we also have to, this is called exploratory data analysis. We have to figure out, it is like, diabetes, non-diabetes.
Mhm.
So when someone is non-diabetic, their sugar level will differ from diabetic or not.
Yes.
So
Basically
that
we
is,
need to categorize our data between two
so
data.
then you have to do the categories. You have to say these are the car with lower speed, these are the car with higher speed.
Okay.
Okay.
And yeah, so
Then
and one more thing, in the real use case, will I be using median? Where do I use it actually?
so remember, whenever your data is having outliers and you cannot deal with it, basically you cannot remove it, then you have to use median. There are approaches. When you go ahead, as you go ahead in machine learning, you will see that what will happen if you have outliers, what to do with them. Okay.
So, sir,
So you
just
will
one
see it.
question. For small data sets, we can visualize if there are outliers, but
Even
for larger data sets, then
there are ways to do that. When you will see graphs tomorrow, you will figure it out. Okay. When you will see graphs, it is easy to figure it out. Okay.
okay.
So the first thing, is it clear how to differentiate when to use mean, when to use median, because that is very, very important. It is how to calculate. I can just show you how to calculate median value also, but when to calculate what is very, very important. That is where statisticians comes in. So it's again, you go for median, click on median, and then just say what do you want for F2 till F7, and it will give you the median value. Okay, so 65.1, 68.0. If you just see this, okay, based on this, it suggests me there is a difference. Is it not 65.1, 68.05? If your data is perfect, as we were discussing, so then they should have been close to each other. Like if it is 68.5, this should have been, just say like 67.8. but it is not. Is it or not? If I just go and enter this 73, now if you see, this became close to each other. It's still not that much, but it's still close. So this is another way. If your mean and medians are very close to each other, it means you don't have outliers. If it is not, then it means you have outliers. Is this point clear? If your mean and median are far from each other, then it means you have outliers in your data. This is another way of figuring it out. Okay, now someone was asking, what if we have 5 or 6 values, then how are we going to do that? So let's see with the same example. Let's say I have another value which is 87. Okay, now how are we going to calculate it? So again, step one is arrange them in ascending order, which is already done. Step 2 is find the middlemost value. Okay, so here the formula slightly differs. So if I say I have 6 values here, so it is even number. So this was odd number. How can we do that? It's very simple, is average of n by 2 comma n by 2 plus 1. So what is n here? How many values I have? 6 by 2 comma 6 by 2 plus 1. So this is 3, this is 4. So what it is telling me, take the average of third and fourth value. So this is my third value, this is my fourth value. So what will be the median? No, median is not third, that is 3.5. So this is the position. Remember, this is the position of the data. So this is your first value, this is your second, this is third, this is fourth, this is fifth, and this is sixth. So third value is 75, fourth value is 82. What is the median average of 75 plus 82? This is what you have to look at. Average of 75 plus 82.
We have to add those value and divide that by 2. Correct?
Yes. So what is the average of 75 plus 82? So this goes like average of n by 2 comma n by 2 and then plus. So here it is average
Then
of
78.5.
third and fourth. Then it is average of 75 plus, which is 78. So is it clear? Technically, you don't have to do anything. Everything will be done here, but this is the way we can calculate median. Okay. The main thing is how to calculate is, still you can go and explore it more, but the main thing is, where are you going to use it? How are you going to use it? Another one is called, is it clear, mean and median? Any question, any doubt with this? What is average, when to use it? What is median, when to use it? It is not clear, Tirupati. So what is not clear? Can you tell me? What is not clear about that?
Can you explain about once again median?
Median is the middlemost value. That's it. When you arrange your data, whatever the middlemost value is, that is your median. Because
Okay.
it is not affected by outliers. Okay. So when you have odd numbers, you have basically you know what is the middlemost value. It's very easy. But when you have even number, you take the average of two middlemost value.
Okay. Okay.
So Sejal, everything will be taken care by the, when we are using it here, everything will be taken care by sheets. We don't have to do any arrangement. They will take care of everything automatically.
So can you please difference between mean and median?
Mean is average. Whatever the average data is, whatever the values you have, they calculate the average of that. Okay, median is the middlemost value. That's it. That is the basic difference. When you are calculating mean, you are adding all of those values and then you are getting a value. Is it or not? Adding and dividing by number of observation. Median is you arrange the data and whatever the middlemost value is, that is your median value. This is the basic difference. Is it clear now? Median is middlemost value. That's you have a data set, whatever the middlemost value is, that is your median value. Average is, we have learning averages like as a kid. Average is you just add all values and divide by number of observations. Is this clear now? Okay. Mode is nothing. Mode is the most frequent value. Most frequent value in your data set. For example, if I say I have these values. I have these values here. So what is the most frequent value in this? Is there any?
No.
No. But if I say I have this data set again, and I have 75 entered twice. Now you tell me what is the most frequent value? 75. So
70.
Mode is nothing, it is most frequent value in your data. Okay. We use mostly it for categorical data to see which category is mostly present in your data set. For example, males and females. So we can calculate mode and see if males are more or females are. If you have educational level, you can see which degree is the mostly present in your data set. Okay, so this is why this is the mode is mostly used over there. Mean and median is mostly used for numerical. So is it clear what is mode?
Yes.
Okay, so your data can have one mode or it can have multiple modes also. For example, you have here two modes, 75 and 87. So if one mode, it is called unimodal. If it is two mode, then it is called bimodal. If you have many, then it is called multimodal. So this is what mode is. How can we calculate mode? We can calculate mode in a very simple way. We just type mode and then we just have to give the value F7 and it is NA because there is no mode in the data. Okay, so if you see mode cannot produce as a result, no values occur more than one. So there is no value. So this is the way we can do that. Mode is simply F2 to F, whatever the range is. If we can also do few things, we can go for the max value in the data set. Simply we say max and then we give F2 column F7 and they enter it, we will get the maximum value in our data set. Similarly, we can calculate minimum value of our data set. Minimum, then F.
Sir, what is the main applications of these all calculations? Why we are doing it? Are
When
we
you are
comparing with other data sets?
first thing is we compare things. For example, like when we will see the data set tomorrow about diabetes, you are going to compare how average value differs from between diabetes and non-diabetes, or median value differs from diabetes versus non-diabetes.
Okay, is that the main application?
Main application is you have to, for example, if you get a data set, you have to present it somewhere. Okay, you do the analysis, you present it somewhere. How are you going to present it? You have to tell, okay, this is the mean of my data set. This is the median of my data set. This is my standard deviation of my data set. All of these we have to present. Okay. Second is compare with one population with another. Okay. Just for example, someone asked me if the car speed is from 10 to 30 and 150 to 200. How are we going to compare it?
Okay.
Okay. So it is comparing two populations, three population, four population. Okay. We can use them to compare it. For example, what if I say how if diabetes versus non-diabetes? Okay, diabetes, non-diabetes, and we have their sugar level. We can compare them using mean. Is it or not? We can calculate mean of sugar between them and then see is it same, is it different? That is why we know the person who is diabetic is having higher sugar level in comparison to non-diabetic.
Okay, okay.
Okay. Okay, so this is what we can simply calculate mean, maximum, all of these. Okay, and if we have maximum, if we have minimum, okay, if we have maximum and if we have minimum, that becomes your minimum. Okay. So range is nothing. This is your maximum minus minimum value. And this is a part of measures of dispersion. So I will explain it and then we will discuss it tomorrow in more detail. Why do we need it? So just for example, if I ask you guys, this is a figure I created, so I want to share with you. If I say, just for example, I have 5 players. Just say Virat Kohli, Rohit Sharma, and Steven Smith, Joe Root, Kane Williamson. So I have 5 players here. Okay. And just for example, all of them have same average score. Okay. So you might have seen like in test cricket or one day, they show the average score of player. All of these players have similar averages, like just say 50. How are we going to figure out who is better, who is not, who is more reliable, who is not? Just for example, you might have heard that Rahul Dravid and Virendra Sehwag both were dangerous. Is it or not? But who was more reliable?
Maximum of the average.
No, it's not maximum average. Average is just give you the center of the data. Your data is falling here. This is what average tells. Your data falls here. It doesn't tell you anything else. So what do we try to see? How your data is dispersed. How much dispersion is present in your data. But because when we compare to population, we also compare how much variability is present in your group. Okay. So for example, Rahul Dravid was more consistent. Is it or not? Sehwag was not. So if you know that, if you have seen the like 10, 12 years back in that era, Sehwag was dangerous because he was, if he scores very much, like 300 multiple times, 280. So he will score like that. That is why his average is very high. But when it comes to Rahul Dravid, he will score consistently. It means Rahul Dravid score has less variability in comparison to Sehwag's score. So either he will score very high or he will go too early. Just for example, if I say Sehwag scored 90 plus 10, what is the average of Sehwag?
50.
Rahul Dravid scored 45 plus 55. What is the average of Rahul Dravid?
55.
50. 45 plus 55. Again, it is 50. Now tell me where we have more variability. Both are having same average. Who is more variable? Who is having more variability?
Sehwag.
Where we are having more dispersion. Okay. So if I ask you, you have to choose one player between Sehwag and Dravid based on the variability, or based on the consistency. Whom will you choose now?
Based on consistency, it's Sehwag.
Consistency and Sehwag.
No. Rahul.
Sorry.
Consistency by Dravid.
Dravid. This is what happens in the data. Because if your data is consistent, what does it mean? It means it is more reliable. Basically means it means your data is perfectly correct and you can do analysis with that. Okay, you are not going to see bias, you are not going to see any error in the data. But if it is inconsistent, it means your data may not be representing the population well and your results may go wrong. So apart from central tendency, we also calculate measures of variability or dispersion. We have to see how good our data is, how much variability is present in our data. If variability is too much, data is not that good. If variability is less, we are good. Is this point clear why we have to check the variability?
Sir, what is that peak is saying and what is the bottom dispersion is saying?
We will discuss, don't worry about that. This is just to show you the variability in the data. We will discuss when we will discuss about skewness, kurtosis, we will all discuss all of them. Okay. But what I wanted to discuss was basically, this is your center. This is when we calculate average. This is what it tells. It doesn't tell anything. Okay.
Yeah.
Based on this, we just know every player is very, very good. Everyone is very good because they have average 50. But when it comes to variability, how good are they?
Yeah.
Then we see the dispersion. The
When it
higher,
comes to performance, we see the dispersion.
then yes, if the data has less dispersion, that your data is good, we can definitely rely on that data. If your data is very high variability, then data is not that good. We cannot rely that much. So if I ask you, you have to play a test match, which is very, very important. So everyone will go for Rahul Dravid because he is consistent player and we know that he will definitely score. But when it comes to Virendra Sehwag, we know if he scores, he can score very big, but he can also get out too early. So there is a risk. Is it or not?
Yes.
So this is what happens in the data also. If your data has too much dispersion, it means their sample collection can go wrong. So you guys might be were asking this question, sir, how will we know how good my data is? So this is the one way to figure it out.
So dispersion should be less.
We prefer less dispersion based on the data, type of data. Just for example, if it is age and if it is salary. So when we see that dispersion, there will be difference in the dispersion. Is it or not? This may be like 5 point something if we will see tomorrow, and this may be like 100, 1000 point something. But this doesn't mean that there is too much dispersion here and there is too less dispersion here. This may be too much dispersion, this may be too less dispersion. That comes with experience. As the more we do, the more we understand. The more the data, the more we understand, okay, if it is good or not. Okay, so is this clear? Why do we have to go for measures of dispersion? That is the point.
Okay.
Is this okay? So mean is alone not enough. Mean is not enough alone. We must have to calculate it with some type of dispersion, which we will see tomorrow. And we will also see some graphs, how to figure out outliers and all of those, using those graphs, when to create what type of graphs.
So the sir, like this measures of variability tells the quality of the data.
It tells you how much dispersion in your data is, which can help you to figure out the quality also. It also helps to figure out when we do the inferential statistics. Just for example, I am doing a study on two population. Okay. And this is the population one, and this is the population. Okay. Population one, population two, and this is the dispersion. Based on this dispersion, can I say these two population differs? Mean is here, mean is here. Just using mean, we can say yes, they are different. But with dispersion, can I say they differ? They differ. They are overlapping. Is it or not? We also use this way. We also use dispersion in this way to see if the two populations are same or they differ. If it is like this, if I say this is my population one and this is my population two, mean is here. Now this is the dispersion. Can I say now the population one and two differs? Because there is no overlap.
Yeah.
This is the maximum value of population one. This is the minimum value of population.
But we can compare the base width for dispersion.
No, this dispersion will be different. But if you see, this is the maximum value, is it or not? And this is the minimum value.
Yeah.
They are still far away, which tells us these two populations differ. And if you have something like this, dispersion is still same. Okay, but they are overlapped. It means these two populations are not. Okay, so we use these things into multiple places. So the first thing is, why are we using this? That is what we have to understand. What is the purpose of to use measures of variability? Why mean is not alone enough? Okay.
Okay.
Okay. So this is why we are discussing. We will start from it here again tomorrow, and then we will see other types of other types of dispersion also. But this is what we have to be sure why we are using central tendency and why we are using dispersion. How they differ. Why central tendency is not alone enough.
Sir, will we discuss how the data is coming into this curve?
So this you will see, like when we will go for the graphs, you will see how to create graphs. When you will go for other like
we'll discuss that now, right?
not in static, we will discuss some bits in statistics. Basically, we will discuss in statistics which data will be used to create which graph. Okay, this is what we are going to discuss. When you will go for Python or Power BI, then you will discuss into much more detail how to create all of these type of graphs, how to interpretation. We will also discuss how to interpret it in statistics. But the best visualization, how to visualize like this, you will see during Python or Power BI.
But thing is how these curves are falling.
So all of this you will see over there. Okay,
Okay.
okay. All of this you will see over there. In statistics, we will also see, but we will see what type of data is used to create what type of graph and how to interpret those. Okay. As you go ahead, you are going to see all of those. So don't worry about that because this is just starting. This is the day one. Okay. Without this, data analysis is not possible. So you will see all of these. Okay. You will not only see, you will be asked to generate like this. And I'm sure like within 2 to 3 months, you will be able to generate figures like.
Sir, can you share the Google Sheet which you have?
So I will share this sheet as well as Google Sheet, which I have created. So just give me 2 minutes. I will share these files with you. Let me
Also
save
the
this one.
doc file.
Here the doc file I'm sharing first, and I will continue everything on this doc file tomorrow also. It is open, so I cannot send it. So let me close this first.
Sir,
And
the
then
recording will be available for reviewing purposes.
yeah, everything will be shared with you guys. So Ravi will explain more detail about that within a minute. But let me share this file.
Thank you.
Yes, recording and everything will be there, so don't worry about it. So any question, any doubt? So tomorrow if you have doubt, we can discuss things tomorrow again. Whatever the doubts you have, we will go ahead with whatever is left and try to see many more. Any question, anything which you want to discuss? Over to you, Ravi.
Okay, Sandeep, I'll take it from you. So thank you, Sandeep. Thank you for the wonderful session and thank you for addressing the doubts as well. So guys, please be in the session. I hope my screen is up. Can anyone confirm over the chat box?
No, it's not visible yet.
Okay, okay. Thank you for the confirmation. So, this is the portal as you have seen in the orientation session. Once you logged in, the dashboard will be like this. Okay. So, in the dashboard itself, you can see your bootcamp course DS56A or DSDA 56. Okay. So once you open that module in the left side under this content section, you can see the content, what all the agenda or module notes or whatever the content is there on the particular weekend. We will be uploading all the contents in the respective week. For example, in this week, we have started as statistics with EDA week 1. So for that, the agenda is this. Okay. So these topics we are covered in the day 1. And tomorrow we are going to cover these topics. So in the same pattern, every week we will be updating in the content section along with the module name and week. Okay, you can check module wise and week wise. So under this, you can find the module notes. Module notes is like a combination of all the weeks. For example, if the statistics is there for 2 weeks, so the module notes you can download from the week 1 itself. All the combination of all the weeks module notes. Okay, so you can access the module notes. Whatever the instructor is explaining, those concepts are you can observe here. So you can just access it from the portal itself. There is no download option. So, and this is a data set for the task. You need to download this data set to work on the task. So this we will show you tomorrow how to work on the tasks and all. And this will be the homework task, the same pattern. Where we have given the data set and here are the questions you need to work on this, and this is completely for your practice purpose. Only assignments you need to submit it in the portal. Okay, so for assignment also, like once we complete the complete agenda, of this week. So I'll let you know in tomorrow's session, like how to work on the assignment and how to submit the assignment. Okay. So try to attend tomorrow's session without fail so that you will not face any kind of questions or anything. So what are the files that have been shared by the instructor during the session in the chat box at the end? So those files will be uploaded at the last, like after the assignment solution beneath of this, we will be uploading those files titled with in-class resources. So you can download it in case if anyone have missed on particular day session. So you cannot able to access the file since you haven't attended the session. So you can directly access those files from the LMS. Okay, this is regarding the contents, and this is class records. Like in case if you have missed the session, so you can access those particular recording from the LMS in the class record section. Once you open your module, at the top you can see class record section. Click on the class records, and below the default will be that this month date range. So you need to change this to this year so that you will be see out all the sessions we have completed, because today 28th, and with this weekend we are going to complete this month. So from next week onward, the default month will be this month means July. So if you want to watch the statistics recording, you need to change this date range to this year so that you can access all the recordings whatever we have completed from here. So since it's a live session, you can see here join now. So once we wind up the session, it will be uploaded as view recording. See here, you can observe that class ended, and within 3 to 4 hours, the class ended place will be replaced as view recordings. Okay, so from here you can access the recordings, and this is announcement section. So what are the announcements we are making? So it will be updated here. So you can check the announcements to not to miss any live session or any updates regarding the sessions. So any questions regarding the portal? You are free to ask. You can text in the chat box.
Sir, daily classes are not available.
This is a weekend session time.
Hello. Sir, is it possible to download the notes, sir?
No, the module notes can't be downloaded for SQL, statistics, and EDA. So there will
Okay.
be download option for Power BI and Python. Since it's a coding part, you will be having those options for them. So for
Okay.
you have to access directly from the portal itself.
Okay, sir.
Now, the instructor files will also be available. The instructor files can be downloaded. You can utilize that for your reference purpose.
So where is it uploaded, sir? Instructor files?
It will be uploaded
Okay.
the assignment solution file. Once after we wind up the
Okay.
we'll make it available.
Sure, sir.
Okay. So coming to feedback section. So as we wind up every session, like not only the weekend session, weekday sessions as well. So once we conclude any session, so you can see here, share your feedback. Since we have completed the orientation session, so you can see here, share your feedback. So click on that feedback. And you can rate the session from a scale of 1 to 10. 9 and 10 indicates that you are satisfied with the session, and any feedback below 9 are considered that you are unsatisfied. So please drop a comment here and submit your feedback so that we'll get to know what areas we need to improve. So according to that, we'll inform to the instructors also. Okay. So I observed that only few students have submitted for the orientation session feedback. So I request everyone, those who are in the session, like 78 participants. So I request everyone to give the feedbacks without fail. Once after we conclude the session, just take a minute of your time, go back to LMS and refresh the page here. So you can see, instead of join now, you can see share your feedback, click on it and submit your feedbacks. So I expect like everyone will give the feedbacks. So any questions are there regarding portal or anything, so that feel free to ask. If there is no doubts, we can wind up the session. And tomorrow we have a technical session at the same timing, morning 10 a.m. to 1 p.m. Don't forget to attend the session. Okay.
Ravi, can I talk to you separately for a minute?
Yeah, Abhishek, you can drop an email success@odinSchool.com. You can reach out to us. Our team will guide you whatever the queries you have personally. Okay. Not only that, in case if you are having any further queries regarding portal or where to watch the recordings or how to access module notes or any questions, just drop an email to success@odinSchool.com so that our team will assist you.
Sir, when will be the doubt clearing sessions?
I'll let you know in tomorrow's session. Okay, Darshan?
Okay.
Detailed date and timing, I'll let you know in tomorrow's session. Okay, guys, that's all for today's session. I hope everyone have enjoyed the session. As I mentioned, please provide your feedbacks. So thank you. Thank you all for attending the session. Thank you, Sandeep.
Thank you, sir.
Thank you.